Andromeda, the nearest large galaxy to our own, home to about 1 trillion stars. And that smaller galaxy behind it? You might think it's the Milky Way, but that's actually Triangulum, another galaxy about 3 million light-years from Earth. Today, we're diving into Andromeda, traveling over 100,000 light-years to reach the center of this galaxy. Our destination is the supermassive black hole at its core. For decades, astronomers knew something massive was there. Stars near the center move at incredible speeds, far too fast unless something enormous is pulling on them. A black hole weighing about 140 million times the mass of our Sun. From Earth, we can't photograph it the way we photographed Sagittarius A star, the black hole at our own galaxy's center. Andromeda is simply too far away. But in this simulation, we can make that journey and see it ourselves. Andromeda stretches over 200,000 light-years across, larger than our Milky Way. For centuries, no one knew what this galaxy really was. Ancient astronomers saw a faint cloud in the night sky, nothing more. By the 1700s, it was catalogued as a nebula, assumed to be a nearby object inside the Milky Way. Many astronomers believed the Milky Way was the entire universe. Then, in the 1920s, Edwin Hubble measured Cepheid variable stars inside Andromeda and found it was nearly 1 million light-years away, far beyond the edges of our galaxy. Today, we know the true distance is about 2.5 million light-years. That discovery changed everything. The universe went from one galaxy to countless galaxies. In 1988, ground-based studies found evidence for a massive dark object at Andromeda's center. By 2005, Hubble tracked a disk of hot blue stars orbiting at extraordinary speeds, about 2.2 million miles per hour, roughly 3.6 million kilometers per hour. Those measurements confirmed what astronomers suspected. A supermassive black hole sat at the galaxy's heart. Andromeda's central bulge is packed with older, redder stars. The center of Andromeda glows yellowish with older stars that formed billions of years ago. The density here is extreme. In our region of the Milky Way, the nearest star to our Sun sits over 4 light-years away. In galaxy cores, stars can be separated by only a tiny fraction of a light-year. At these distances, the night sky would look completely different. From Earth, we can see a few thousand to about 6,000 stars with the naked eye under dark skies. In the innermost core of a galaxy, you could see vastly more, potentially millions in the densest regions. So many stars that the night would never be truly dark. The gravitational forces in the galactic core are intense. Depending on how close a star is to the center, orbital periods range from decades very near the black hole to millions of years farther out in the bulge. Our Sun takes over 200 million years to orbit the Milky Way's center. Andromeda is on the order of 5 to 10 billion years old. In that time, countless stars have formed, lived their entire lives, and died in this core region. Some exploded as supernovae, others collapsed into neutron stars or black holes, all of it happening around the supermassive black hole at the galaxy's heart. From Earth, astronomers can barely image this black hole. The Event Horizon Telescope photographed Sagittarius A star at our galaxy's center in 2022. And in 2019, it captured the first image of a black hole in the galaxy M87 55 million light-years away. But Andromeda's black hole sits in between. Too far for the detail we get from our own galaxy's black hole, and its nucleus is crowded and faint in X-rays, making it extremely difficult to isolate. It remains one of the more challenging nearby supermassive black holes to study. A black hole weighing as much as 140 million suns. Too faint to image directly from Earth. But here, in this simulation, we can see it up close. Here it is, the black hole at the heart of Andromeda. The event horizon, the boundary where gravity becomes inescapable, stretches about 827 million kilometers across, roughly 514 million miles. About the distance from the Sun to Jupiter. Anything that crosses that line is gone. Black holes come in different sizes. The smallest ones form when massive stars run out of fuel and collapse. These stellar black holes typically weigh a few tens of times the mass of our Sun. Then there are supermassive black holes like this one, millions or even billions of times more massive than the Sun. Almost every large galaxy has one at its center. No one knows exactly how supermassive black holes formed. They likely started billions of years ago when the universe was young and grew over time by accreting gas and merging with other black holes. At the very center sits something called a singularity, an extremely small region where all the mass is compressed. The laws of physics, as we understand them, break down there. Occasionally, a star wanders too close. The black hole's gravity pulls harder on the near side than the far side, stretching the star into a long stream of gas. And time behaves differently near a black hole. The closer something gets to the event horizon, the slower time moves from an outside observer's perspective. A clock falling toward the boundary would appear to tick slower and slower, eventually seeming to stop. It's likely been here for much of the galaxy's history, quietly sitting at Andromeda's core, a massive object at the heart of our nearest giant galactic neighbor. Silent, faint, and powerful.